Hello all, good morning. This is Dr. S. Subalakshmi, an assistant professor in the Department of Mathematics, SNS College of Technology. This is a DT-based video on the topic, evolute of a given curve. So first of all, the students are going to explain what is an evolute, how come it is approachable with DT, and the approaches of the real-time application problems also. So we'll have the students one by one and we'll explain all of the slides here. Here we have the key point as the importance of the concept. The concept explained through the design thinking approach. The third time is real-time applications, two problems, case studies we are going to see. And in the next thing we are going to solve the given problem here. Next slide. So what is an evolute of a curve? The evolute is nothing but the locus of centers of curvature, which is nothing but the points, the centers of curvatures, points are joined and we have a path there. That particular path is called as the evolute of the curve. So what is the geometric meaning? It shows where the curvature is greatest and how it changes along the curve. So the curvature can be measured with the help of this evolute also. And what is its design relevance? It really reveals the hotspots. Wherever the particular curvature is high, wherever the particular curvature is low. Like so it will reveal. So this is the mathematical preliminaries regarding the evolute. This will be explained by the students.
Mathematical preliminaries. For a planar curve parametric or y of equal to f of x, curvature k and radius r.
So curvature k and radius r is given, which means k is nothing but the kappa and r is nothing but 1 by kappa. Kappa is the curvature here. We have a formula to find the curvature and radius of curvature. The next slide.
Evolute coordinates for y equal to f of x.
So this is nothing but the coordinates for the center of curvature. Ex is nothing but the x point and Ey is nothing but the y point. And we will use this as the base for finding the radius of curvature, center of curvature and circle of curvature.
Evolutes min of r, max of k, kappa and evolute, focal deviation.
So these are the concepts which we will use the evaluation.
Evaluation steps apply to an evolutes. For each VP step, we will evaluate using these categories: stakeholders and the empathy matrices.
The first point to be noticed is stakeholders and the empathy matrix. Second point,
Quantitative matrices, formulas, thresholds.
so the formulae and the thresholds are to be noted as a second point, which comes under quantitative matrix.
Stimulation prototypes, what to stimulate, how.
So simulations and prototypes are to be checked up, and what to simulate, how to simulate it, that things are to be noted.
Instruments and measurements, tools and tolerances.
So instruments which we are in need of doing this evolute process and measurement we are in need of doing this evolute process are also to be noted.
Acceptance criteria, pass or fail thresholds. Apply these 5 evolution categories at each VP stage.
So the acceptance level is also to be noted, and also all these steps are to be included in our 5 stages of DT.
Ideal curve y is equal to ln x, empathize. Goal, measure user driver needs constraints. Evaluation action. Stakeholders, drivers, transport, engineers, maintenance crew. Record typical speed, vehicle maximum. Data collection, accident records, comfort survey, lateral acceleration, complaints. Empathy matrices.
Empathy matrix, the target matrix lateral acceleration, which is A lateral should be less than or equal to 0.3, gravity for comfort. And maximum allowed steering torque, statistical distribution of vehicle speeds are also to be noted. These are the points of empathizing in the design thinking approach of evolute.
Define goal, convert empathy finding into precise problem statement with the measurable targets. Evaluation action, problem statement, reduce section where r less than r minimum. For design speed, v into d.
So quantitative targets are to be noted here, and we are evaluating the quantitative targets wherein we have this theta as the
Banking angle, here friction coefficient.
and we are going to specify that v into d, which is for example you can take this 100 km/h and we are calculating this r minimum. Later,
Identify constant state, available land, site, distance, drainage, cost limit.
so these are the thresholds we are in need of in the this defining stage. Acceptance.
List of measurable constraints satisfied. R greater than or equal to R minimum across curve.
So which means this is the list of measurable constraints which are to be satisfied in our defining process. So if this is satisfied, we will move on to the next.
Candidate geometric fixes and scoring. Evaluation actions. Candidate ideas. Flow-type transition. Increased binding. Widen lanes. Local straightening.
So these are the ideas to be infused in our ideation concept.
Scoring criteria. Safety 40%, cost 20%, constructability 15%, driver comfort 15%, maintenance 10%.
So these are the percentage of weightage for the exact criteria given.
Quantitative evaluation. Compute resulting curvature K of S and radius R of S for each idea. Compute peak lateral acceleration for design speeds.
These are nothing but the curvature and radius of curvature at the particular point as per the given problem.
Select top concept for prototyping based on composite code.
So what we have got as a score, with that type we are going to type the we are going to specify the type given.
Produce geometric prototypes and validate via simulation and small scale tests. Evolution actions, digital prototype, CAD model of chains alignment, compute y, y dash and y double dash numerically, generate, evaluate and RFS.
So this is a digital prototype wherein we will be using the CAD lab techniques to find y, the first derivative y dash, the second derivative y double dash, and we will evaluate the evolute and the radius of curvature.
Simulation, vehicle dynamic simulation, multi-body or parcel to compute lateral axis, yaw, steering input.
So these are the simulations we will handle in the particular CAD unit.
Physical prototype, if possible, scale model or real driving simulator. Measurement instruments, GPS or IMU data for test vehicles to record lateral acceleration. Acceptance criteria, maximum lateral axle is less than or equal to threshold, no upward curvature jumps, d kappa by ds below limit, evaluate free of cups in redesigning segments.
So she have explained the acceptance criteria on this particular level. With this level only we can move on to the next level.
Test. Goal. Final validation and iteration plan. Evolution action. Field test. Instrumented vehicle runs at target speeds. Record lateral accelerations, steering effort, skidding events.
So these are the field tests to be done prior to testing.
Monitoring metrics. Percentage of runs exceeding a lateral threshold, braking events, driver feedback.
So everything are to be monitored as a percentage. Next is
Post-construction step. Pavement marking,
site distance verification. These are to be done after the verification process. Next is
acceptance. Greater than or equal to
less
2%.
than or equal to 2%.
Less than or equal to 2% runs exit lateral
Acceleration threshold, and no new incidents in 6-month monitoring has been done. So this is the acceptance level, and also if it fails to decide or attain that category, it will return to the ideate or prototype with the redesigning rules. So as I have said you, if this is failing, we will move on to the previous step, we will work on it and again come to this testing process.
Parabolic mirror y square is equal to 4ax. Empathize. Goal. Measure optical performance need and stakeholder constraints. Evolution actions. Stakeholders. Astronomers, optical engineers, end users. Gather image resolution spec. Example arc seconds. Spectral bands. Environmental constraints. Empathy metrics. Required modulation stands for function MTF. Permissible focal spot radius. Manufacturing tolerance.
So this is our empathy part wherein we will calculate this MTF function and permissible focal spot radius and manufacturing tolerances which will be measured by mu_m. So this is considered to be the measures of this parabolic mirror wherein the equation is y squared is equal to 4ax. Next is the data collection.
Data collection, required aperture size, operational wavelengths, allowable aberration budgets.
So these are to be collected.
Success evidence, documented image quality targets, instrument interface events.
So these are our success evidences produced wherein we have documented the image quality targets and instrument interface limits.
Goal. Translate needs into measurable optical specs tied to evolute behavior. Evolutionary actions. Problem statement. Ensure deviations of actual center of curvature from ideal less than or equal to delta across mirror surface.
So this is our problem statement, and with this only we are going to define the statement.
Quantitative targets. Focal error less than or equal to specified lambda by 4. MFT at specified spatial frequencies, surface figure error RMS less than or equal to target. Constraint, fabrication techniques limits, thermal deformation limits. Acceptance.
So what do we have to accept? Computed evolute derived curvature center falls within the delta tolerance and predicted optical performance meets the MTF function defined earlier in the previous step.
Goals, generate shaping and correction strategies, evaluation actions, candidate ideas, latent parabola machining, iterative polishing guided by evolute derived corrections, active objects, sub-aperture testing and correction, scoring
So
criteria.
these are the ideas to be given by the candidates, and the scoring criteria is also given as the weightages.
Scoring criteria, optical performance 50%, fabrication feasibility 20%, cost 15%, long-term stability 15%. Quantitative evaluation, for each method, estimate residual surface error, network correction maps, and predicted focal spot size.
So in this quantitative evaluation, we are in need of calculating that residual surface error. This is in nanometer, and also we are in requirement of correction maps and predicted focal spot size of the parabolic mirror. Selection methods, that mean RMS and MTF are to be also targeted.
Prototype. Goal. Build and measure prototypes and corrections. Evaluation actions. Prototype types. Small mirror segment, partial pupil test or procurement of full mirror polished into first figure.
So whether that mirror can be applied as this type or that type have been mentioned here.
Measurement methods. Interferometry, profilometry, shaft hardening, reference sensing.
So these are the methods of sensing for the particular parabolic mirror have been given, and we are translating it.
Translate measure wavefront errors into curvature deviations and compare to evolute positions.
So each of the curvatures are to be noted, and the curvatures in the particular radius of curvature is also noted, and we are about to find the evolute also.
Stimulations. Ray trace mostly parallel to estimate TSF and MTF with measured surface error.
So this is an application used as a computerized digitalized thing, which is a Monte Carlo step. Acceptance criteria. We have the surface RMS to be less than or equal to the specifications, and the focal error to be less than or equal to the target given. This is what we are in need of.
Test. Goal operational validation and monitoring plan. Evaluation of actions on style optional.
Optical test, which means the telescope.
Point source imaging. Measure TSF, fill ratio and MTF.
So this is nothing but PSF is nothing but the point source imaging that is to be measured, and MTF, the previous state functions, is also to be measured. Next is
Environmental risk. Thermocycling, gravity status, use active correction with meter.
so environmental tests are to be performed, and the acceptance level is also given here. Likewise, we will perform the testing procedure also.
Final summary. At each design thinking steps, we use clear evolution, matrix, straightforward matrix, mathematical results, stimulation validation, measurement instrument, acceptance criteria. Evolute is the grading concept.
Evolute is the bridging concept here. It maps with the geometry and the engineering decisions. In each of the slides, we have seen all these steps: stakeholder metrics, mathematical thresholds, simulation validation, measurement instruments to be used, and acceptance criteria. Each of the slides we have noted. With this, the evolute concept is mixed up with the geometry and with the engineering decisions.
The same DT evolution workflow.
And DT evaluation workflow is also noted, wherein the empathizing concept, defining concept, ideation, prototype, and testing are also given here, which gives
Repeatable, measurable design outcome for both safety, highways, and
precision. So, for safety and precision, our design thinking concept have given a much direct approach and a much clearer vision towards the goal. Thank you.